What's up, guys? This episode we're going to talk about using state machines in your Rails application and how to install them and use them. So if you're not familiar with what a state machine is, take a look at the episode I've linked to in the notes and above in the YouTube video, where I basically just explain what a state machine is. This is something just really to keep track of the state of an object in your system. So this is something that is really, really useful in software, and a lot of places are going to be using this, especially stuff sort of like background workers. They're going to need to keep track of the state and transition things around. And this is really crucial, especially when you're using something and doing something complex like you have a vehicle. So if you have a vehicle, you want to be able to define the state that initially it's parked, but when you go from parked to anything, you want to put on the seatbelt, and then after a crash, you want to tow the car, and after a repair, you fix the car. So long as you define all these things, your system should be working correctly. But the real trouble is when you're trying to define this elsewhere. If you're trying to define this in regular code, you have to have so many little things in there. So when we go from parked to anything, then we have to put on a seatbelt. You can't do a regular active record update from the parked state to something else and then just know that it's going to work. So this state machine gem is really, really helpful to make sure that you're getting things done, like put on the seatbelt method. This is also very awesome because it allows you to define which transitions are valid. So if you call the park event, then it will only transition from idling in first gear into parked. You can't take it from fourth gear immediately into parked. That would be dangerous. So it helps you define all of the rules in a reasonable format. I think this is probably the best that I can think of that you would use to define this in Ruby, because state machines can be quite complex and have quite a few rules, and really, this is long for an example implementation, but when you look at all the stuff that it does, it really takes a lot of the vehicle attributes and the required functionality of a vehicle and defines it reasonably cleanly. It's a lot of code, but vehicles are also very complex. So you can even see down here, I believe there's a second state machine for the car's alarm, which is really interesting because you can have multiple state machines for the exact same object, which means that the car's alarm might be on, it might be off, all of those things, and you can trigger that even from various other things like your other state machine. So this is really interesting, and it allows you to say, when the car is parked, let's override the speed of the car and always force it to 0, which is really interesting as well. So you can take this stuff and you can basically override these methods as necessary throughout your system. So the state machine gems are pretty fantastic, and there's another one called AASM, which is very similar. It seems to be more recently maintained. I've had to fork the state machine gem itself to include a few patches to work with the latest version of Rails. But yeah, take a look at both of these because they're also very similar, but I think pretty fantastic. So this one defines states in a little different manner, and you can do pretty much the same things, I believe. I haven't seen anything that you couldn't do in one or the other. It just kind of depends on the syntax that the two support. So take a look at both of these. I'm going to show you how we could use the state machine gem in Rails and take this and basically lay out what payments flow might look like with our state machine. So I've got a payments app here that I just created, and there's nothing in it. So the first thing that we have to do to set up our state machine is we need a model with an attribute for the state. So if we create a payment model, so maybe we have a product that we're paying for, maybe it has an amount that's an integer, and there's a state on the purchase. So the state needs to be a string. So you can generate a model with that string column, and you can run rakedb migrate. And this will basically set everything up for the foundations of this gem. So I'm going to go down here at the bottom, and we're going to add the state machine gem. And you can do the same thing with ASM. It's pretty much exactly the same flow. I'm going to grab the GitHub version from my state machine fork just so that we have that. Then we can run bundle to install that. Okay, so now that that is installed, we can open up the payment model, and we can start our state machine in here. So this state machine, as you can see on this vehicle model, has a whole lot of stuff here. And really, the piece that you need is this first line. You need to say state machine state, and this is going to be the symbol for the attribute that you are saving to the database. Ours is called state, so that's great. And then you can set an initial value, and so ours might be pending because we're working on payments. So maybe as soon as you create a new payment, it's pending. And we know payments that have like started, or people who have maybe started, but they haven't necessarily gone through and started processing this. So we have probably a few states that we want to create. So we want pending, and pending could go to processing. So imagine this happens in a background worker or something. We can do the processing in the background. And then from processing, we could either have a successful payment or we could have a failed payment. And then we can also refund the successful payment, but not a failed payment. So this is sort of just the flow, and this is a state machine that really just flows in one direction and doesn't really loop around or anything. So it's a more simple state machine, but it still has to go through these steps. It's important for us to set these events that are going to happen. So we'll have these events, and these will be the things that transition the state from one to another. So you have to have an event that happens. And basically you're going to do something like process, and this will transition the payment from the pending state to the processing state. Now, this is something that you can see here in these examples. You can transition from idling or first gear to parked. You can transition from stalled to also stalled, or parked to idling. So this is something that we're going to define here. So when you start to process a payment, you're going to go from pending to processing, and then we're going to have events that our payments processor. So imagine you have some code in the background that's doing this. Once it's in the processing state, you can have a fail method, and you can transition from processing to failed, or you could have a success event where you transition from processing to successful. And then the last one that we want to define here is we want to have a refund where it could transition from successful to refunded. Now, all of these are really just going to transition the states on the object. So let's take a look at that in the Rails console. So let me clear this out and run Rails C here. Let's create a new payment. We'll call it P. And we've actually defined fail, which is a method that we defined here basically that has already it's already on the object. So I'm not exactly sure where it comes from, whether it's active record base or the state machine, but the fail method's already there. So let's just change the event name to failed. So this should allow us to reload, create a new payment object, It is working this time. And our state is automatically set to pending. And if you'll notice, we didn't set a default in our active record migration. So the state would by default be nil, except for in this case, because the state machine gem automatically sets that up for us to set it to pending. So here we can say payment dot process. So if you call the event that you have chosen here, this will actually save the record and transition it to that state. So here you can see that when we call it process, it has transitioned to the processing state. So this is maybe when your user sets the processing, or maybe your user puts the credit card in, you save this payment, and then it sets itself to processing. And then your background worker picks it up and says, okay, now that we're processing, let's see if the payment fails or succeeds. So then your code in the background can do one of two things. One, it could say, okay, well, it failed, so let's tell it to transition the state to failed. And when you call p.failed, it will call this event and transition from processing to failed. So now you can see that we have a failed payment. And if you were to try to do something like success here and transition it from processing to successful, it won't succeed and you will get false in return because the state that it's currently at, failed, doesn't allow that. And you can also do various things here where you can ask the state machine if it can do something. So here's an example in their example, README. You can see if you can do various things. So can you ignite? So we could say can success, and it will tell you false, and it builds these methods dynamically. So you could see, actually, can we take this payment to the successful state? Well, no, we can't because we're currently failed. So it provides all these various helpers and shows you the transitions and the state events and a bunch of stuff like that that allows you to use these helper methods in a way that it can generate them and you can just interact with it in a more fluid manner. So this is really cool. And we can create a new payment. So let's just override the P variable and we'll create a new payment. And here we can say, okay, process this payment. The payment was a success. And now we have the ability to take this to can refund. And it will say true because we do allow that now. So what it's doing behind the scenes is it's saying when you say can refund, it looks for that event for the refund, and then it says if your state is currently successful, then we can transfer you to the funded state. And that's basically all it's doing behind the scenes. It's looking to see if it matches any of these transitions that you set up, and will tell you true or false if that is allowed. So it's really pretty simple behind the scenes, but it's got a lot of stuff set up for you. So this is cool. We can call refund, and that will refund the payment. Now, there's a lot of things here that you're probably thinking is like, okay, well, you just transitioned these states, and the only thing that changed on the object was the state. So how do I actually call the refund code, say from Stripe or Braintree, when that happens? And you're basically going to set these up as these callbacks. So here's a couple examples of various things that you can do for those transitions or those callbacks. So you have a couple helpers here to set up callbacks for before transition, after transition, and around transition. And you can set these up so that it will happen just like your before filters, your after filters, and your around filters in controllers. But there's various things that you can do. So around transition benchmark, I believe we'll call the benchmark method. This one here is a little bit different, and you can say when you transition from parked to anything, but anything other than parked, then call the put on seatbelt method. And this after transition says when you go from anything to parked, then we'll just run this code right here, which sets the seatbelt to off. So rather than setting up a put or like a take off seatbelt, they have just done this in line with a block. So you can do either one. And let's set up one of those in our application. So let's do an after transition. Let's do after transition from pending to processing. Let's do a process Stripe payment method. So let's define that, and then outside of the state machine, you can make a process Stripe payment method, and here you could call this Stripe charge.new and do all your code for that. And then basically, if it's successful, then you could call the success method. Otherwise, you could call the failed method, and this would then transition the state machine from one to the other. So let's do something like this and say if it's true, then we'll automatically move on to success. So we should be able to go into our console here, create a new payment, payment.new, payment.process, and this should actually go from processing to successful for us. And it does. So what is happening then is when you call process, we go from pending to processing. The state machine knows when you go from that transition from one to the other, you should try to process the Stripe payment. And then in here, it knows that, well, if it was successful, then let's transition to success. And if it failed, then we can transition to failed. And this can all happen in a flow like that. And you can define your methods over here outside of the state machine to do the processing itself. So after transitions and before transitions are great when you want to do all of this stuff immediately when the transition happens. For example, if you wanted to do this in a background process, you could still write the same method, but you would, rather than adding the after transition, you would delete this, and then you would call process Stripe payment from your background worker, which would just look for payments in the processing status, for example. So this is great to do this in line, and then you can also do something like a before transition, and you could say, well, let's take successful payments, and when they go to refunded, we should process Stripe refund. So this is one of those cases where you actually want to do this before it fully transitions, because refunded would be the final state, and that would assume that it has been successful. So you want to do it before the transition happens, and we can do process Stripe refund, and this can be the one that tells it true or false, like does it allow this to actually happen. So this could be some code in here that attempts the Stripe refund, so it would be like Stripe charge retrieve whatever, and then I think you can call the refund method on it, or however the Stripe's API is defined. So you would be calling something like this inside of here, and then once that's finished, as long as it didn't cause any problems, you would then be able to have this go back and finish the transition, and so this would just run before it finishes, which means that if this fails or something like that, you can catch it before it actually marks it as refunded. So imagine that this actually raised, let's just raise a standard error here, but imagine that it raised a Stripe, like we couldn't look up the charge, or it doesn't exist, or something like that. So it raised a Stripe error. If you were to do that, and let's reload this. Let's get that last payment out of the database, which is a successful payment. if we were to call a refund on it, we would get something like this that would blow up, and that would be bad. But the good thing here is that even though it failed, it didn't go ahead and update our payment to refunded. It caught it before that happened. So it would be definitely a bug in the system if your code crashed, but it said it was refunded, and then your customer thought they were refunded, but they really never were. That's a really dangerous bug to have in your code. So make sure that you pay attention to the proper transitions that you're doing here, because that is a crucial piece of writing good software. So you want to make sure that you're doing that stuff logically so that these transitions don't happen on accident. And that is the main thing for you to look out when you're writing a state machine. You're going to make sure that all of the requirements are defined and processed successfully before the transition actually happens, if that's the way that the transition should work. Since we could probably talk about this gem for hours, I want to just touch on one last thing here, which I think is really useful, which is the state blocks. So the state block example here is that we only really want to validate the presence of your seatbelt being on in the first or second gears, which means that if your car is parked or it's idling, then we don't really care so much if your seatbelt is on or off. This is something that's really awesome because it allows you to do this rather than trying to put an if option on here with a lambda and write a bunch of code in line. It allows you to define this in a much cleaner way, and we can do things that are really awesome. So let's get rid of this before transition and the error that we were raising. But imagine that we want to have a method that only shows up when the payment has been refunded. Here we can simply say refunded state, and we can define a method here. So maybe we have no refunded at column in the database, and we want to have a refunded at method here. So maybe we want to define this, and this should return the time.zone.now. This is as simple as it would have to be for this method to only show up during that refunded state. If you call this method and you're on successful state or processing or failed or pending, it will throw an error because this method is not available, which is really nifty. It allows you to organize your code, and then you can't call this method. So we have it already protected by putting it inside of the state block. If you didn't have it in here, you would have to move it out, and you would have to make this method down here. And first, you would have to say let's return nil if state is not equal to refunded. So you'd either have to do something like this, or you'd have to raise an error. So you could raise some sort of error, and that would be awful as well, because now you're putting all this stuff inside the method, and it's well, you're not supposed to be able to call this, so we need to protect it. And it just goes on, and it becomes kind of a painful thing where every one of these methods that only applies to refunded has to do this. And this is the kind of code that you would have to write all over the place if you weren't using the state machine gem. So imagine that you got rid of all of this. You would have to say your methods would be process, and then it would raise standard error if state is not equal to pending, so that you couldn't process from the successful state or the refunded state. And then you would do your processing code. And all of those methods you could define manually without the state machine gem, but you'd have to do all this stuff like that, and you'd have to put in all those rules inside of your code, and then it becomes quickly an unreadable thing. And that is the beauty of having the state machine gem, because it allows you to define it and all of the rules, and it takes care of handling those exceptions and the transitions and everything about the validations between the two without having to write all of your own checking code that could easily be written poorly and you can miss something. But this is defined in such a way that you don't have to worry about it, and the state machine gem will take care of it for you. So that was kind of a whirlwind intro to the state machine gem. I hope you enjoyed it. I definitely recommend using it. It does get a bit unwieldy once you start having a lot of events and things going on. So this is also something that you may want to pull out of your model and put it in a concern and include it just so that you can make that model a lot more readable. It can be a little bit overwhelming because of how much code you have to write, but at the same time, it does allow you to protect the transitions of your objects throughout the system, and that alone is worth the kind of headache of having a couple hundred lines of code to define your state machine. It would probably take you more than a couple hundred lines of code to do this outside, and you're going to save yourself from a lot of problems by defining a state machine in your Rails app. I hope you enjoyed this episode. If you have a favorite over state machine or AASM, let me know in the comments, and look forward to talking to you next episode. Peace.